Alrighty, my friends. Okay, so we are going to do a couple of these together, and then you're going to do the rest by yourself. So I'm going to, let's read this first problem down here together. So read it out loud with me. Marcy runs 1 4/5 miles on Monday, 2 1/5 miles on Tuesday, and 1 2/5 miles on Wednesday. She uses a number line to record her running record. Which number line does not represent Marcy's run? Okay, so here we jumped 1 4/5 to 2 1/5 to 1 2/5. Well, that looks pretty much the same, right? Because if we have these three fractions, well, that's exactly what we just hopped. Here, they hopped the wholes of all three of these, and then they hopped the three fractions. Well, they hopped from 0 to 1, 1 to 3, and that would be 2, 3 to 4, and that would be 1. And then they hopped 4/5 and 1/5 and 2/5. Well, that's the same thing, right? Do we end up at the same spot on the number line? Yes. Okay, so, but we want, remember that we want the one that's not represented by the number line. So this can't be it, and this can't be it. Well, let's look down here. Uh-oh. Do you see any of the fractions that are up here on this number line? I don't. Do you? No. Okay, so that might be our answer. Let's put a little question mark next to it. Down here, they jumped the fractions first, and then they jumped the whole numbers. Well, that looks fine to me too, so that can't be the answer. So that means that our answer is H. Okay? All right, so let's look at number 3 up here. So it says, Sarah's mother wanted to bake a cake. Her recipe calls for 1 2/4 cup of brown sugar and 3/4 a cup of white sugar. What is the total amount of sugar required for the cake recipe? Okay, so she's baking a cake, she's got this sugar. So it says total amount of sugar. It doesn't say brown sugar or white sugar. It says amount of sugar, right? Total, that's important. That tells us that we're going to be doing what? Adding or subtracting? Adding. So these both are subtracting, so I can automatically eliminate those guys. Okay? Now, let's go ahead and add these the way that we've learned how. So we've got 1 2/4, and we've got 3/4. Well, we don't need to convert that because it's already a, fraction. But we need to go ahead and convert this to an improper fraction. So 1 times 4 is 4, and we need to add 2, and that's going to equal 6. 6 what? 6/4. So we need to add 6/4 plus 3/4. Well, what's that going to equal? What's that going to equal? 9/4, right? Rookie mistakes. Rookies would add and make that 8, but we're not rookies, are we? Okay, so now I need to do 9 divided by 4 to find out what this would be in mixed number form. How many groups of 4 can I get out of 9? 4, 8, 12. 12 goes over 9. We can't do that, so it's just 2 groups. 4 times 2 is 8. 9 minus 8 is 1. Okay? So let's remember how we set this up as a mixed number now, because we've got these 3 parts, right? Let's remember what they equal. So what's going to be my whole here? What's my whole? How many whole groups of 4 could I get out of 9? How many whole 4/4 could I get out of 9/4? 2. And then what's my part left over? 1 out of 4. So which answer says which one says that it equals 2 1/4? A. Right there. Okay. Go ahead and flip her over. Let's look at number 2 down here. Read this out loud with me. Billy and Jason raked leaves in the backyard. They had 10 trash bags for bagging the leaves. Billy used 2/10 of the bags. Jason used 3/10 of the bags. And then later their friend Michael came over to help, and he used 2/10 of the bags. What fraction of the bags were not used? Okay. So let's think about this for a second. So I've got 2/10 plus 3/10 plus 2/10, right? So what does that equal? What's 2 plus 3? 5. What's 5 plus 2? 7 thirtieths? 7 1,000ths? No, Miss Hartgrove, we're not rookies in this Aggie classroom. 7 tenths, right? Okay, guess what? Automatically tried to trick us. Look right here. They said 7 tenths of the bags. Guess what? Those were the ones that we did use. We did use. Those are the ones that were used, okay? So we used 7 tenths. They want to know the ones that were not used. Well, if there were 10 trash bags altogether, they had 10 out of 10, right? Well, I need to find the difference between what we used and what there was altogether. So I need to subtract 7 tenths. What's 10 minus 7? 3 over 0? Over 100? Over 20? Over 10, right? We're not rookies. Denominator always stays the same. Say that out loud with me. Denominator always stays the same. Okay? So the answer is J. 3 tenths of the bags. All right, let's check out this one. Elizabeth, oh, I'm sorry, not that one. This is not here. The table shows the number of coins in Amanda's wallet. So she's got 6 pennies, she's got 1 nickel, she's got 3 dimes, she's got 5 quarters. So it says, what equation can be used to find the fraction of coins in Amanda's wallet that are pennies or dimes? Well, first of all, we need to find out how many coins there are altogether, right? Well, what is 6 plus 1 plus 3 plus 5? Well, what's 6 plus 1? 7. What's 3 plus 5? 8. Okay. What's 7 plus 8? 15. So if there's 15 coins total, and they want to know pennies or dimes, pennies and dimes, we don't really, care about nickels or quarters. So we have 6 and 3. Well, what is 6 plus 3? That equals 9 out of 15. So we need the one, which number sentence do you see that says 6 fifteenths and 3 fifteenths is 9 fifteenths? Which one? This one? This one? This one? What about this one? 6 fifteenths plus 3 fifteenths equals 9 fifteenths. Okay, answer is J. Your job is to do number 1 and 3 on this side, and do number 1 and 4 on this side. Okay? Shouldn't be too hard for you. Okay? If it is, feel free to come in the morning and review your math journal entries that we've already done. And what do I want from you the most? What do I want? Uh-oh, I'm upside down. I want you to show your work. Show your work, right? Right? Yes. Okay. All right, guys, thanks for watching. Oh, and guess what? I messed up this whole thing. Okay, thanks for watching, guys. I will see you.